Guys, I'm Professor Bill Mwanza, and I want to take you guys through a topic in Form 2 known as Hooke's Law. Okay, let's start with the Hooke's Law. And the Hooke's Law, as you know, it's a law. Now let's start defining the law. The law states that the extension produced on an elastic material is directly proportional to the force applied or the force produced, provided that the elastic limit is not exceeded. Now that one can be expressed as in form of an equation, that is the force is directly proportional to extension, whereby if we want to remove this direct proportionality, we equate there with an equal sign. It will be force is equals to Ke, where the K is the spring constant. It is varied, but in the same material, it is equal the same in the same material, or equal in the same material. Under which condition? As long as the material is the same, or the material used, the elastic material used is the same, the constant will remain the same. But it varies with the different materials. Now let's look for the SI unit of this constant. We can rewrite this formula by making the constant the subject of the formula. How do? We divide both sides by extension, this side by extension, and our constant will be force over extension. As you know from the basic knowledge of Form 1, the SI unit of force, it is newtons, and the SI unit of extension is the length. It just means that the difference in the length, or let me say that for you to find the extension, you have to subtract the initial length from the final length, whereby the final length, it is the length that has elongated after the material has extended. Now the extension, it is measured in meters, that is the SI unit. Okay, now our constant will be force over extension, whereby the SI unit will be in newtons per meters. When you divide newtons divided by meters, you will get newtons per meters. Okay, let's look for an example. Example one, and say that from the question reads a force of 8 newtons. You have been given force as 8 newtons. A force of 8 newtons makes a spring extend by 2 millimeters. Now the extension is 2 millimeters. Now determine the spring constant of the spring it produced, or the spring used. Now we are looking for the spring constant. From this formula, we are told that constant is equals to force over extension, and we have been given force as 8 newtons divided by extension as 2 millimeters. Now our answer will be 4 newtons per millimeters. It doesn't necessarily mean that any question you have to give the answer in SI unit, but if you have been given a condition that the answer must be in SI unit, now that is when you'll convert these 2 millimeters into meters before dividing. Okay, I think this is for finding the constant. Let's look for example 2. Let's look at example 2. Example 2, it says that a spring whose spring constant is 0.2 newtons per centimeters. Now here we will be given the spring constant as 0.2 newtons per centimeters. It extends by 15 centimeters. Now the extension is 15 centimeters. Now when a force is applied on it, determine the magnitude of the force. Now this is just the force. The magnitude means the average force, or the total amount of force used. Now that is the average force, or the magnitude of the force. Now from the formula, we say that force is equals to Ke, and our force, we are looking for the force. Now our constant is 0.2 newtons per centimeters. Our extension is 15 centimeters. Now if this centimeters, the value of extension, or the value of length here, the unit of the length here, okay, the constant will be given as this one, and the extension as this one. if you have identified that the extension, the units of extension varies, is the same as the units of the extension in the constant, which is centimeters. The centimeters and the centimeters are used, then you go ahead and use it the way it is. But if, for example, the constant is centimeters and the extension is in meters, now you have to convert these meters into centimeters for you to work out the question and find the answer correctly. Now here we'll use it directly the way it is, because we have centimeters and we have centimeters. We'll say force is equals to constant, which is 0.2 newtons per centimeters, multiplied by 15 centimeters, whereby this centimeters cancels with this centimeters. You will remain with force is equals to, now if you take 15 times 0.2, you will get your answer as 3.0 newtons. Okay, don't worry about these others. These are just mathematics. For information, next class we will be doing mathematics in the same class. No, now don't worry about this one. This one is just other things away from whatever we are doing. We are looking at Hooke's law. Okay, this is the second equation, the second example. The first example we were looking at the constant. The second example we have been looking at the force. Now another example, you can be given an example or a question that you are supposed to find the extension of the material. Now you just apply the same formula. Okay, let's focus for only for the two, because they are the basic ones. We are looking for the constant, force, and extension. No reason for us to getting another example that we are supposed to look for the extension, because the formula is the same. Let's look for the final example, maybe, which is comprised of maybe two parts. For example, part A, part B, part C, that can make a student to be challenged. When you have failed the first part, maybe you can fail the remaining parts. Or if you have gotten the first part, you have that reason to get the remaining parts. I can just look for one example. Now let's call it example 3. Example 3 says that part A state Hooke's law. From our definition, we just say, even you have a reason to use the formula, and you explain for yourself and give out the answer. Force is equals to Ke. Now Hooke's law states that the extension produced on an elastic material is directly proportional to the force applied on the material, given that the extension limit does not exceed. This extension limit, we'll look at it maybe when we are doing away with this topic. When we are drawing the graphs, you'll see how the extension limit affects the material. Now let's look for that example. That part A, we have been told that such Hooke's law, which says that the extension produced on an elastic material directly proportional to the force applied, given that the external limit does not exist. Now part B, it says that an object of weight 20 newtons, weight is equals to 20 newtons. From the basic knowledge of Form 1, we know that weight is not an example of force, but weight is another name of force. Now this means our weight is the same as force. It's like we have been given the force that is provided on the material is 20 newtons. Now the force is 20 newtons. Attached at the end of the spring causes an extension of 0.5. Now an extension is equals to 0.5 centimeters on the spring. Now the part B, Roman 1. Determine the spring constant of the spring. We are looking for the spring constant. This is the same way. This is the same example with the example 1. We said the constant is equals to force over extension, whereby our force is 20 newtons divided by extension, which is 0.5. Now this will be 40 newtons per centimeters. Because we have not been given conditions that the answer must be in SI unit, now we have no reason to convert this extension unless you have some more time for you to convert this extension from centimeters to meters, and you get your answer in newtons per meter. But this is the correct answer. Even that one will also be the correct answer. Let's look at the second part of part B. Because example 3, we say that determine the weight of an object that will cause an extension of 0.86. Now this is B Roman 2. Now we are being asked to find the weight. The weight is the same as force. The force of an object that will cause an extension of 0.86 centimeters, when attached at the end of the same spring or the same material. When the material is same, it means that the constant, it remains the same as 40 newtons per centimeters. And because this centimeters rhymes with this centimeters, now we can look for the force, whereby we say force is equals to KE. This will be our constant, which is 40 newtons per centimeters, multiplied by extension, which is 0.86 centimeters. The centimeters cancels with the centimeters, will remain with the force is equals to 34.4. Force is in newtons, not centimeters, sorry, in newtons. And this is our final answer. You can find that an example, like example 3, carries somehow like 6 marks, because this is 3 marks, this is 2 marks, and the definition is 1 mark. Those are 6 marks. It has contributed to a grade. Now, this is the part of introduction to Hooke's law. Now, Hooke's law, we have seen the definition, the formula, the SI unit. Now, the basic examples of finding the constant, the force, and the extension. And maybe next lesson, I'll be taking you through the factors affecting the spring constant. Those are the factors affecting the spring constant. We'll look at it next part. I can't take as much time as possible. I can't take the longer time, maybe okay. I'll not take much time, maybe to talk about all of Hooke's law, factors affecting, maybe graphical representation. I can't take the whole day to take you through the whole topic. Now for today, we'll stick with this basic knowledge of Hooke's law, and maybe let me ask you, as my viewer, may you view, subscribe and share for you to see more and more. I'll be presenting physics and mathematics, and probably if you have any question, maybe you can contact on this number. This is 0746954678, and the name is Professor Bill. Professor Bill. Yeah. Thank you for your time.